Right, then today we will take the next trigonometric function to find the dy by dx, y equals tan x. Write down number 3 as y equals tan x. Y equals tan x. Of this, the function y equals tan x, we are supposed to find the dy by dx. Right. So then what we do, by the definition of the derivative, we can write dy by dx how, people? Limit delta x going to 0 if x plus delta x minus fx divided by delta x. This is the definition of the dy by dx. Okay. Now our fx is this. Then this one is really on the right hand side. Whatever you have the function, it's every x we have to replace by x plus delta x. That means for every x you have to write x plus delta x. So then if I do so, we get dy by dx limit delta x going to 0, right? Limit delta x going to 0. If x plus delta x mean really this tan x is your fx, then it's x we have replaced by x plus delta x. Understood? Right. Tan x plus delta x minus tan x divided by delta x. Divided by delta x, people, right? Okay. This is what we get. Now, this is what do next. Dy by dx limit delta x 1 to 0. People, this delta x is divided by delta x. I can write 1 upon delta x. 1 upon delta x, right? Dividing by delta x mean really multiplying by 1 upon delta x. That's true, no? Right. So then we have really, people, here tan x plus delta x minus tan x. No, this tan we write as sin by cos. Sin x plus delta x divided by cos x plus delta x minus tan x we can write as sin x divided by cos x. Okay. Now what we do, secondly, people, within bracket, for this fraction minus this fraction, we take common denominator as the product of this and this. Okay. Then we get dy by dx limit delta x going to 0, 1 over delta x. Here this and this we have to multiply cos x plus delta x into cos x. Then this cos x, by this cos x you should multiply this. By this cos x plus delta x you should multiply this. Then we get sin x plus delta x into cos x minus cos x plus delta x into sin x. Right. People, now here this x plus delta x angle, it is an angle, no? This x plus delta x, if I take as A, here also, people, we have A. This angle x, if I take as B, this is also B. Then, people, you know, this takes the form sin A cos B minus cos A sin B. Sin A cos B, sin A cos B minus cos A sin B form comes within bracket. People, you know, this kind of expansion, sin A cos B minus cos A sin B, that expansion is coming by the trigonometric formula sin A minus B. Can you remember that? Sin A minus B. So therefore, I can write this as people really sin A minus B. Right? I told you at the very beginning of the trigonometry lesson, this trigonometry is very important lesson throughout this combined maths course. So then you can see that, the truth of that. Right. So then this sin A cos B minus cos A sin B, this whole along expression now we can of course shrink. How? Write in that sin A angle is this, B angle is this, taking the difference of A minus B. So then I can write people dy by dx is equal to limit delta x equal to 0 1 upon delta x, right? The numerator going to be sin A minus B, x plus delta x minus x, right? A is your x plus delta x, B is your x, divided by what? Cos x plus delta x into cos x. Right? This and this you can cancel down. That you can cancel down. Then we get people what? Dy by dx limit delta x going to 0. Now within bracket we arrange like this. Here we have sin delta x, no? Sin delta x divided by delta x. That too we write together like this. Sin delta x divided by delta x. Okay. And now rest one we have is this people. 1 upon cos x plus delta x into cos x. This way we have. Of this whole thing, we have to take the limit of delta x going to 0. People, in the limit lesson, we discussed when we have a product like this, and if you need to take the limit of that product, that can be done taking individually of the expressions the limit. So therefore, in this case, what I am trying to tell you is people, the limit delta x going to 0, we have to apply on this term as well as on this term, right? So what you get here, limit delta x going to 0. So now you can very clearly see here, this takes the form, this delta x if we assume as sine theta by theta, then this is sine theta by theta, theta going to 0. Then this is 1 according to that limit lesson we learned. And here we have delta x 0, because delta x 1 0 means the same delta x here we have, that is 0, but this x1 change. Then this bracket is cos x, this is cos x. Understood? So therefore we get dy by dx as people, when you put 0 here, 1 upon cos x and cos x here, 1 upon cos squared x, cos x into cos x. And here, this is 1. Then cos x is cos squared x. 1 upon cos squared x means people sec squared x. That into 1 is sec squared x itself. Right. So then we get d upon dx, d upon dx tan x. Y is tan x, no? Here, this y is tan x. The derivative of tan x is sec squared x. So this is our next result. Right, people? You should know how to take this result. Right, start. Right. Okay, people. Okay. Right. Those who finish this, come to number 4 as fourth one. Take people the fourth one. Y equals sec x. Fourth one, y equals sec x. Right. Right. I'll give a few minutes, people. Try to get this answer. Y equals sec x. Right. Now, in this case, people, this fx function is sec x. Fx function is sec x. Okay. Right. Yeah. Now, next one, people. Right. Next one. You can write the next step here like this. This delta x I write like this. 1 over delta x. Sec x plus delta x we can write as 1 upon cos x plus delta x. Right? Sec means people 1 upon cos, no? Right? 1 over cos. Minus sec x means 1 over cos x. Okay. Now what we do here, people, again we take the product of these two as a common denominator. Then here 1 over delta x coming. This is cos x plus delta x into cos x. Right. So now when you take product of these two as a common denominator, this cos x comes here minus cos x plus delta x comes here. Now to simplify here, we take this x as c, x plus delta x as d. Then here, people, we have to apply cos c minus cos d formula. In trigonometry, can remember cos c minus cos d formula? See here, everywhere we find this application of trigonometry, right? Cos c minus cos d. What's that? Cos c minus cos d is 2 sin c plus d by 2 sin d minus c by 2. Sin d minus c by 2. Right? Sin d minus c by 2. Then here we can apply like that. Dy by dx limit delta x going to 0, 1 upon delta x, 2 sine. First, people, this angle x and this x plus delta x we have to add. X plus delta x means 2x plus delta x, right? Last time also I discussed this, right? This is sum of this and this that we have divided by 2. X and x, 2x. Then p divided by 2 means we get x. And this delta x should be divided by 2. This is what we get for c plus d by 2. Understood? So therefore 2 sine c plus d by 2 going to be x plus delta x divided by 2. And the other one is sine d minus c. Right? This x should be subtracted from this. X plus delta x minus x means it is delta x. That should be divided by 2. Sine delta x divided by 2. This is what we get. Right. Now, in the next step, we write this way. People, this delta x, we write below this. Sine delta x by 2 and this delta x we write here. Because this product we should divide by this delta x. When you divide a product by something, people, all the terms in the product no need to divide by that. Only one term we should divide. So therefore I divide this by delta x. And this sine x plus delta x by 2 we have here. right? Like this. Now people, what I can do here is this. This 2 we have no. That 2 I can write where? Here. Now that 2 don't write here. First listen to me. This 2 I wrote here. Then I write here dividing this delta x by 2. To cancel down this 2, I write another 2 where? Here. Then this 2 and this 2 we can cancel down. The same thing to this one. Sine delta x by 2, this one. Divided by this delta x here we have. Then you can cancel down, people, this 2 and this 2. Then what has happened? Finally, when you cancel down, you can see this 2 has come below this delta x by 2, below this delta x. Understand? So that way you can think now, right? So then finally, people, this 2 you can bring where? Here. So in other words, people, you can think this also, this way also. Now 2 divided by something, delta x. This we can write, people, 1 upon this 2 we can bring below this delta x, like this, here, like this, delta x by 2. Understand? That means, people, here, this one is really what? 1 divided by delta x by 2, this one. This division sign I can write as a multiplication, no? Then take reciprocal. Then 2 upon delta x coming, no? Here, this way. So therefore, this 2, in other words, people, we can bring below this delta x by 2. That way also you can think. Right. Now what I do, people, I take the limit, this delta x going to 0 for this and this separately. Here, limit delta x going to 0, and here, limit delta x going to 0. That is because of when we have a product like this, and if we need to find the limit of that product, people, okay, that limit we can apply for both. Right. In addition to that, people, this denominator cos x plus delta x also we have. That I forgot to write. Here we have that also, cos x plus delta x into cos x. Cos x plus delta x into cos x, right? Here, that I am going to write. For that also, I am going to apply the delta x limit going to 0. This is here dy by dx. Right. Now you can very clearly simplify this. Here, delta x going to 0 mean delta x divided by 2 also going to 0. That you can understand. That we explain well in the limit lesson. Here, this delta x by 2, when you take as theta, sine theta divided by theta. Now this theta going to 0. Delta x going to 0 means delta x by 2 going to 0 normally. So then, people, this answer will be 1. This is 1, right? This whole answer is 1. This is 1. When I put delta x 0 here, this is sine x. When I put delta x 0 here, this is cos x, this is cos x, right? Then we can write it like this, dy by dx, right? This is 0, then sine x we get. And they are 1. Divided by, this is 0, cos x and cos x, cos squared x. Cos 6 I wrote. Then I can consider this as separate. How? This sine x divided by cos 6, first we consider. Multiplied by 1 upon cos x, secondly we consider separately. 1 over cos x is, people, sec x. Sin x by cos x is tan x. Then we get tan x sec x. Tan x sec x means, people, sec x tan x, right? And then we get derivative of sec x is sec x into tan x. This is, people, this is the way of getting the derivative of sec x. Right. Right, now take number 5. Y equals cosec x. Take number 5 as y equals cosec x. Take number 5 as y equals cosec x. Right, I'll give a few minutes, people. Try to do that. Cosec x. Write down by the definition here. Right, now here fx plus delta x means, people, this cosec x plus delta x minus fx is cosec x divided by delta x. Cosec x plus delta x, people, I can write this delta x, I write as 1 over delta x, open the bracket. This cosec part we can write as, cosec means 1 upon sine x plus delta x minus cosec x is 1 over sine x. One over delta x. Now take the common numerator here. Sine x plus delta x into sine x. The product. Then this sine x comes here. This sine x plus delta x comes here. This way. Now you can take, people, this x as the angle C, this x plus delta x as the angle D. Then really here you get sine C minus sine D form. Sine C minus sine D form. Then there you get dy by dx as limit delta x going to 0, 1 upon delta x this sine x plus delta x into sine x, I write like this, 1 upon sine x plus delta x into sine x, right, within bracket. And this is now sine c minus sine d. Can you tell me, people, sine c minus sine d formula? 2 cos c plus d divided by 2 sine c minus d divided by 2. Right? Sine c minus sine d formula begins 2 cos. When we have sine c minus sine d, it begins saying 2 cos c plus d by 2. Second one is sine c minus d by 2. Understand? Then it is, right, 2 cos at these angles and divide by 2. What do you get? X plus delta x by 2. Second one is sine, right, c minus d. X plus delta x should be subtracted from this x. Then what do you get? X minus, within bracket, x plus delta x means when you remove the bracket, what do you get? X and x will cancel off, minus delta x. That should be divided by 2, minus delta x by 2. Minus delta x by 2. Like this we have. Minus sign we get. Right now, people, what we do next is this. Here we have within bracket minus sign. This is like sine minus theta. Sine minus theta. Sine minus theta means minus sine theta. This minus sign you can take before. That minus sign you can bring before here. Okay, then we can take that at the very beginning of this minus, right? Now this delta x and this 2, right? Now here we took this sign minus sign out now, people. Then there we have sine delta x by 2. This minus sign we have taken out. By this delta x, we must divide this, so this. Now I am going to divide this by this delta x. Then I write delta x below this. And this 2, I can bring below this delta x. Then here I write that this way. As I told earlier, people, this 2 we can bring to the denominator of the denominator, right? This 2 I can bring below the level this. Below the level this means below the level delta x. That means delta x by 2. That means we can write 2 divided by delta x. We can write as of people 1 over delta x by 2. That's what I have written here. Now what I do, people, this limit we apply for this separately, and this separately, right? We'll write that limit delta x going to 0. We apply that. And now we apply that for this. What, people? Limit delta x going to 0 for this cos x plus delta x. Cos x plus delta x by 2. And the next one I am going to apply for this, right? Limit delta x going to 0. 1 upon sine x plus delta x into sine x. Minus limit delta x equal to 0, 1 over sine x plus delta x into sine x, like this. Right. Now, people, you can see here we have minus sign. When delta x is 0, this is 0. Then here we have sine x, here we have sine x. Correct? And here delta x is 0 means this is 0. Then this bracket will be cos x. But what is this, people? Delta x going 0 means delta x divided by 2 also going 0. Then here we have sine theta by theta, theta going 0. That is 1. Understood? Delta x going 0 means delta x divided by 2 also going to 0. This is therefore 1. Right. So now we can write this way. Dy by dx is equal to minus. When you put delta x 0, this is 0. Then it will be 1 upon sine x into another sine x here. Here delta x 0 means cos x. Here this is 1. Right. People, now this one sine x I take here, cos x by sine x. Then we get cos by sine is cot. Another sine x, here we have 1 upon sine x. 1 upon sine x is cosec x. Here we have minus sine. Then what do you get? Minus cosec x into cot x. Therefore, the result is minus cosec x cot x is the derivative of cosec x, right? Therefore, you get d upon dx. Cosec x is, people, minus cosec x into cot x. This all result you should remember, and meantime you should know how to take this result. d over dx cosec x is minus cosec x cot x. This is how we take that result. After these people, the number 6 we can take the next one is y equals cot x, right? After finishing this, start to take the derivative of y equals cot x. Take y equals cot x. Right. Now, let's see how to take this answer here. Right. Now, here cot x plus delta x minus cot x divided by delta x. Cot x plus delta x we can write as people, cot means cos by sine, no? Cos x plus delta x divided by sine x plus delta x. Here you have cot, no? Cot means cos by sine. Minus here cos x by sine x. Now again people, here we take the product of these two as the common denominator. This 1 over delta x we keep like this. Sin x plus delta x into sin x. Then by this sin x you should multiply this. By this sin x plus delta x you should multiply this. Then what do you get there? Sin x times cos x plus delta x minus cos x plus delta x times sin x. This way. Okay. Now here we take this angle x as A, then here also A. This x plus delta x we take as B. This is B. Okay. Then you can see here, this takes the form sin A cos B minus, wait, I have made a mistake. This is really sine, no? This sine should come here, no? Right. Correct, no, people here? I have made a mistake here in writing. This sin x should come here. Sin A cos x plus delta x minus sin A cos B minus this cos x must be written here. I have made a mistake there. Yeah, really. This cos x should be multiplied by sin x plus delta x. Correct, no? When you take the common denominator as the product of this and this, right? By this sin x, you should multiply this. By this sin x plus delta x, you should multiply this. Then sin x into cos x plus delta x minus cos x into sin x plus delta x. So if I take this A as A, then here also A, people. If this is B, this is also B, right? Now you can see here, people, this one you can say sin A cos B minus cos A sin B. That expansion is coming by what, people? Sine A cos B minus cos A sine B. This kind of expansion is coming really by people sine A minus B. So this whole thing you can write by this way, sine A minus B. And then I can write dy by dx equals limit delta x going to 0, 1 upon delta x. This one numerator we can write as sine A minus B. A is this, B is this. When you subtract this from this, x minus within bracket x plus delta x. X minus within bracket x plus delta x. Then when you remove the bracket, x and x will cancel off, but that delta x is in bracket will be minus delta x, right? Sine minus delta x coming here. And divided by sine x plus delta x into sine x. Sine x plus delta x into sine x. Okay. Now, what we write next is, people, you know, in this sign, the angle is negative. Then this minus sign you can take out, because you know in trigonometry we learned sine minus theta is equal to minus sine theta. Tan minus theta minus tan theta. But cos minus theta is cos theta. By cos you can't take that minus sign out. Then this minus sign you can take here, that we can take where here. Minus. Limit delta x going to 0. Then this minus sign we took sine delta x, and we divide that by this delta x. And now we have here sine x plus delta x in sine x, delta x going to 0 like this. 1 upon sine x plus delta x into sine x. Okay, people, now what is this answer? This is 1. When I put delta x 0 here, this is sine x, this is sine x. It is sine squared x. Dy by dx is equal to minus 1 upon sine x into sine x. Dy by dx is therefore, people, 1 over sine x into sine x means 1 over sine squared x. 1 over sine squared x is cos x squared x. Before that we have minus sign, this is minus cos x squared x. And that means the result here, y is cot x, no? D over dx. Cot x is therefore, people, minus cos x squared x. Right? This is how we take that. Right, people, that is how we take the derivatives of trigonometric functions. Okay. Right. People, now we'll come to the next one. Derivative of exponential function. You know, exponential function is defined by ex, right? Ex, right? Can write now next one, derivative of y equals ex, exponential x, exponential function. This ex is called as the exponential function. Right. Try to take this derivative of ex, Start, people. Take the derivative of ex. Right. Now people will come to that one. The dy by dx we can write applying this definition, limit delta x going to 0. Right. This function is on the right hand side, we have write for every x plus delta x. So then this will be e to the power x plus delta x minus fx means again this ex divided by delta x. This e to the power x plus delta x you can write e to the power x plus delta x you can write as people e to the power x into e to the power delta x. Correct, no people? So then bases are equal when they are multiplied. The exponents we have to add no to simplify this. Then x plus delta x come in. Right. And minus e to the power x divided by delta x. Now this ex is common, people. Take this ex out. dy by dx. Take this ex out. Limit delta x going to 0. Ex we can take out. Then we have within bracket e to the power delta x. Once I take ex out, we get there 1, here delta x. Now people, here we have a product. Of this product we have to take the limit delta x 0. Then this limit delta x 0 we can apply for this separately and this separately. dy by dx. Limit delta x going to 0 e to the power x times limit delta x going to 0 here e to the power delta x minus 1 divided by delta x, like this. But people, you know, though this delta x going to 0, can remember the first lesson we discussed, though this delta x going to 0, the x one change. Therefore this x1 change means people ex1 change. Then that same ex we get here too. And this one, people can remember in the limit lesson we discussed limit x going to 0 e to the power x minus 1 divided by x. Here the power of e here we have at the denominator the same value only going to 0. Then we notice this answer is 1. Therefore e to the power delta x here, the same delta x here we have, the same thing here going to 0. This is therefore 1. Then this is ex into 1. That is nothing but people ex. So therefore the derivative of ex with respect to x is the same ex. Same ex, right? Same ex. So therefore derivative of ex is ex. Right. Derivative of ex is ex. Okay, that means when you differentiate ex with respect to x is people ex. Right. Okay, now people suppose this way. We have y equals x plus 1. We increase this x. We we increase this x by, we put, for example, people, suppose here, we put x equals 2. Then what is the y value? 2 plus 1, no? Y value is 3. Right. Now we increase this x by a little value. This is denoted by delta x, no? Suppose that is 0.0001. Then what's the new x value? Early x value is 2. New x value, this 2, we have to add this one. Then new x value going to be x plus delta x, no? It is 2 plus here 0.0001. For this new x value, people, you can find new y value. What can you say, people? Substitute for new x value here. Right, then what do you get? 2 plus 0.0001 is the new x value plus 1. Then you can see here 2 plus 1 is 3, 3 plus 0.0001. We will now see here, earlier when x equals 2, the y value is 3. Now after increasing x by a very small value delta x, we found the new y value. New value y value also, people, earlier 3 plus certain increment of this new y value we have. And that says, people, as we increase x by very small value, the y also, right, increasing by a very small value. Okay, right. So then in general, without taking like this, the increment of x without taking like this, I denote this increment of x by this notation delta x. I am going to take increment of x as delta x, right? People, now you can see the increment of x, this delta x, it's a real number like this very small value. The corresponding increment in y also a very small real number like this we have. Now people, I can write this way. You know, when we have 3 by 2, 3 by 2 you can write as, people, 1 upon 2 by 3. That means this 3, you can bring the denominator of this 2. 3 by 2 is equal to 1 upon 2 by 3. Like that, we can write, people, delta y divided by delta x. Delta y and delta x are two real numbers, no? Then you can write this as how, people, 1 upon delta x upon delta y. This way you can write. Now what I do is, people, in left hand side and right hand side, I am going to take limit delta x 0. I am writing limit delta x 0 in the left and right. Right, this way. Okay, this is limit. On the right hand side, delta x 0, when I write, we get 1 over delta x upon delta y. People, what is the meaning of delta x going 0? Here we said what? This delta x is this much. Delta x going 0 means this value will be coming to 0. Delta x going 0 means this is not 0 but very close to 0. Delta x going 0 means this figure is gradually coming to 0. If delta x 0 means, we notice this is 0 now, people. Right? Then x plus delta x is 2. If that delta x 0, this is also 0. Then this is also 0. People, what can you say? If delta x is 0, obviously delta y is also going to 0. Understood? Delta y is also going to 0. Right? Then limit delta x going to 0 mean, once this delta x going to 0, parallel to itself, people, delta y also going to 0. Delta y also going to 0. So therefore, I can write limit delta x going to 0, delta y divided by delta x is equal to this one. You can write limit delta y going to 0, 1 upon delta x upon delta y. Correct, no, people? Delta x means what, people? Delta x means the increment in x. Right? If x increases by delta x, y also increasing by a little value, we take that as delta y. If there is no increment in x, then there should not be increment in y also. That means if there is no increment in x, means people that increment of x we assumed as delta x going to 0, no? Then due to the increment of x by delta x, the increment of y should also go into 0. Understand, people? Now that is to say, in the morning, right, you have 100 rupees. Before you leave home to classes or wherever, people, you had 100 rupees. Now suddenly your mother or father gave you 50 rupees. Now your amount of money increased by 50 rupees, and there you have 150. Okay, due to the giving 50 rupees by parents to you, your amount of money increased from 100 to 150. Now suddenly, right, that parent asking back that 50 rupees. Then again what happened, people? Your extra amount going to 50 going to 0, and you will be at the same value 100 rupees, like that. Delta y is what? Increment of y. Due to what? Due to the increment of x. If x increases by a little value only, y increases. X increased first by delta x. Due to that, y increased by delta y. And finally, that increment of x is coming to 0. That means no increment x. Increment of x is delta x, no? It is coming to 0. No increment in x. If there is no increment in x, means no increment in y also. Delta y coming to 0. Therefore, on the right hand side, here delta x going to 0, I can write as delta y going to 0. Now people, what is the notation here we applied? When we define the dy by dx, we said the way of defining dy by dx, we said that delta y divided by delta x fraction we must have. In that fraction, this denominator should go to 0. Here, delta y by delta x, the denominator should go to 0. That location, this whole thing we write in this delta letter as dy by dx, and it is called as what, people? Derivative of y with respect to x. Come to right hand side. Look at this, people. Here we have delta x divided by delta y. Delta x divided by delta y. And in this ratio, this delta y, the denominator going to 0. Understand? Then tell me, according to this here, delta y by delta x, the denominator going to 0. Then this is denoted by dy by dx. Here, delta x upon delta y, the denominator going to 0. Then this should be denoted by dx by dy. This delta letter we have to replace by d. So therefore, the result this we get dx by dy. Then this is another very important result, people. Dy by dx. Dy by dx. What is dy by dx? Derivative of y with respect to x. It is equal to 1 upon dx upon dy. What is this dx upon dy, people? Derivative of x with respect to y. Understand? I'll explain further what is the difference between this dy by dx and dx upon dy. Understood? Right? Yeah, people, now we have to come to what? That theory part. Right, the theory part you can write like this. Write down this way, the heading write down. Put a star mark. To prove the relation dy by dx is equal to 1 upon dx upon dy. Right? This is the relation. Right now? Okay. Write down like this. Let y be a function of x. Let y be a function of x. People, what is meant by y be a function of x? We can write y, its right hand side we have in terms of x. That's the meaning of y be a function of x. This way. Write down. Suppose the increment in x, suppose the increment in x be delta x and corresponding change in y, be delta y. Write down, then by simple algebra we may write delta y divided by delta x is equal to 1 upon delta x by delta y. Delta y by delta x is equal to 1 over delta x upon delta y. This way we can write. Write down now, people. Now taking limit delta x 0 on both sides. Delta x 0 on both sides. Right here, this way. Now you can write but as limit delta x going to 0, limit delta y going to 0. As delta x going to 0, people, parallel to that, meantime, simultaneously, delta y also going to 0. We can write the right hand side this, delta x going to 0 as delta y going to 0. This way you can write. People, now the notation we assigned, the notation we assigned for this. See here, delta y by delta x. Here and here we have delta letters. Numerator y, denominator x. The denominator delta x only going to 0. Then this whole thing, limit delta x going to 0, delta y by delta x. For this whole thing only, people, we give dy by dx. That occasion, this delta letter by change into d letter, the whole thing we give another notation called as dy by dx. This is now dy by dx is equal to. Then here, people, delta letters available x, y, and the denominator one is going to 0. Then accordingly here we can give a notation for this one dx by dy. Okay, it is equal to 1 upon dx by dy. Right. This is the required relation. Understood? Right. But people now here, I'll explain this relation. I can explain it like this, people. See here, y equals sin x. For the y equals sin x function, people, we found the derivative. There we found what, people? Dy by dx as cos x. Then people here, this is how we think. On the right hand side of this, we have x. That x only in the dy by dx to the denominator coming. Understand? Now another one, suppose here y equals sin u. Then what derivative we have, we can find here, people? What derivative we can find here? Right hand side letter is u. Left hand side is y. Then we can find dy by du. Dy by du. Understood? Okay. Then what is this answer? Sin u. Sin u, we differentiate with respect to u, then cos u. Okay. Suppose like this, z equals cos t. What is right hand side letter t? Then what derivative we can find? dz by dt. The right hand side letter coming to the left hand side denominator. Cos t. When you differentiate cos x, that means if we have like this, people, y equals cos x, what is the dy by dx? We proved minus sin x. Here, this x come in here. Like that, people, here, z equals cos t. This t is now here. Then dz upon dt is minus sin t. Okay. Now, people, suppose like this. X equals sin y. X equals sin y. Then, what is the derivative we can find? Yeah. X equals sin y means, people, right hand side we have y, no? We can write dx upon dy. Understand? Right? Dx upon dy we can find, because right hand side later only come into left hand side denominator. What is this, people? When you differentiate sine, what do you get? Cos. Can remember when we have sin x, what is dy by dx? This x is the left hand side denominator later. This is cos x. Like that, here x equals sin y, then we can write dx upon dy. Then sin y, when you differentiate, we get cos y. Now we have the answer of cos y. People now think here, if we need to find dy by dx, if we need to find dy by dx, in order to find this, people, definitely we should have the function y in the left hand side. In right hand side, its right hand side, we should have in terms of x. Then only we can find dy by dx. Now, in this case, people, x equals sin y. Then always the right hand side later only come into left hand side, you know, no? Then we can find dx upon dy. But given like this, okay, ask him to find what is dy by dx. You know, since on the right hand side we don't have x, directly you can't find dy by dx. That occasion, people, we get help of this relation. What is dy by dx then? Then dy by dx, people, we can obtain how? It is equal to by the rule 1 upon dx upon dy, no? But dx upon dy here we have as cos y. Putting that way here, we can take the dy by dx. That sort of use, people, we have in this formula. Understand? In this formula. Understand? By using this, we can do some, what, people, theories. Okay? Right. Right. So now, we come to one example to do under this, and thereafter we go to the some theories. Right. We will come to this. Question is here. If x equals sin y, find dy by dx. Find dy by dx. Write down. If x equals sin y, find dy by dx. Start here, people. X equals sin y. Right answer letter is y. Then we can differentiate and we can find what derivative, people? Dx upon dy. Dx upon dy. Dx upon dy. Right? We can find dx upon dy here. Now dx upon dy, we can write, people, what? Right hand side letter only, in the left hand side denominator we have, right? Right. So then x equals sin y, dx upon dy we can find, people, here. Right? Think like this. This is how we think, people. No need to have any hesitate mind here in understanding this. If the right hand side we have sin x, the derivative we can write is dy by dx. Then differentiating the sin x with respect to x, we got the answer cos x, people. Same way we have to think. Right hand side y, that comes here, then dx upon dy we have. Then sin, when you differentiate, we get cos. Right. This way we get cos y. Understood? That's how we think. Right. Now we need what? Dy by dx. Now we use the result this. Now using dy by dx is equal to 1 upon dx upon dy. We get what, people? Dy by dx is equal to 1 over dx upon dy is cos y. Cos y. But, people, cos y you can write. But you know, in trigonometry we learned, people, cos squared y plus sin squared y as what? 1, no? For any angle theta, we learn sin squared theta plus cos squared theta as 1. Then here we can subject cos y. First of all, we subject cos squared y, taking this right hand side, 1 minus sin squared y. But, people, in our question, we are given this sin y as x. That means here sin y is x. So therefore here it should be x squared. 1 minus x squared. This is cos squared y. Then take the square root on the right hand side like this, we get 1 minus x squared. We'll take positive square root. Now cos y we know, people, put that way here. Then we get the dy by dx. Therefore we can write dy by dx as what? 1 over cos y means the square root of 1 minus x squared. So this is how, people, we find dy by dx given that this way relation. Understand? Okay? Right. So therefore you have to very carefully understand, when in this case when we consider, people, since y is on the right hand side, this is called as x is the function of y. X is the function of y. Right hand side letter is y. That is why it is called as x is a function of y. Then we can find dx upon dy, not dy by dx. In order to find dy by dx directly, left hand side we should have y, right hand side we should have x. Understand? Now given like this, x equals sin y, asking to find dy by dx. Then directly you can't find dy by dx. We can find directly dx upon dy. Then the way of converting that dx upon dy to dy by dx is by means of this rule. So that is the importance of this rule. Right, people, take the first answer. Use of this rule. right? Right, now using this, we'll write the derivative of y equals L in x. Write down, next one, the derivative of y equals L in x. People, this L in x mean, right? L in x mean, people, L in x is the logarithm of x to the base e. When the base of this log is e, that is written as L in x, right? Yeah. Now, you know what is meant by e. E means, people, we learned a function called as exponential x, exponential function, ex. In the limit lesson, we discussed that. The graph also we discussed, no, people. Ex we define like this, no? 1 plus x upon 1 factorial, x squared by 2 factorial, and so on. This goes up to infinity, no? That is the ex. Its base is e. When you put x equals 1, we get the value of e. It is nearly 2.71. That also we calculated, no, in that lesson, right? Now, let's see here how to take the derivative of L in x, right? So then y equals log x to the base e. Okay, people, how do we convert this kind of logarithmic form to index form? Yeah, you can convert this how we learn log, people. Logarithms we learned. This log term we remove from the right hand side. We keep this x on the right hand side, and the base of log is e, no? We bring this e to it, what left hand side, then we keep this left hand side y as the power of that e. So therefore, you can write here, people, what? This implies e comes here and e to the power y is equal to what? This 6. Correct, no, people? You know, 100 equals 10 squared. How to convert this to logarithmic form? Log 100 to the base 10 is 2. Now, using this logarithmic form, how to convert that to index form? Eliminate this log term from the left hand side. Keep this 100 in the left hand side. Bring this 10 the base of log to right and keep the power 2. That's what I did here. I eliminated this log, brought this e to left now, kept y as its power equal to what? X. X equals e to the power y. So this means, people, again this way. Y equals x means x equals ey. Now in this way, when we consider on the right hand side we have y, then what is this, people? X is a function of y. Then what derivative we can find? Dy by dx or dx by dy. Dx by dy, we said the right hand side, later only, people, come into the left hand side. Then dx upon dy only we can find. Then we can write, differentiating, we can write dx upon dy. Now tell me, what is dx upon dy? People, now think like this. If we have y equals ex, today we learned derivative of y equals ex is what, people? Dy, the right hand side one only come in here, no, people? Dx. Dy by dx is equal to ex. Okay. Then if we have like this, z equals e to the power u. Then what is dz upon du? Also the same thing we get. Understood? Right? And like that, people, when you have here x upon e to the power, x equals e to the power y, people, dx upon dy should come as again e to the power y. Understand? Right? And then this is e to the power y. Why? After differentiating ex function, the same answer coming. That's the reason. Like that here, dx upon dy is equal to e to the power y. Understood? But what we need really find, people, dy by dx. Then we get use of that result today we proved. Okay, right. Now you can write but dy by dx is equal to 1 upon dx upon dy. Therefore, we can write dy by dx is equal to 1 upon dy is people e to power y. But what is e to power y here? E to power y is x. So therefore, for the place of this e to power y, you can put what x? Dy by dx is people 1 upon x. Now by this we can take the next result. What is the next result, people? Next result is this. What is this y? Y equals here ln x. Then substitute for this y, then we can write the result like this. Therefore, d upon dx ln x is equal to 1 upon x. That means when we differentiate log x, but log x, the base should be e. When the log x has the base e only, we write that as ln x. Now people suppose something like this, y equals log x to the base 10. When the base 10 is there, people, you can't differentiate like this 1 upon x. Yes. Here you should have the base e. This e is in the exponential function, that e. That occasion only, people, when we differentiate dy by dx, the answer is coming as 1 upon x. What is x? This x only coming, people, as the answer at the denominator. Okay. Ln x means, therefore, remember, people, logarithm of base e. Understood? Right. Okay. Take down that result. Right. Now, using this result, people, we come to another few more theories today, right? Derivative of inverse trigonometric functions. Write down. Derivatives of inverse trigonometric functions. Right. First one, we take y equals sine inverse x. Y equals sine inverse x. Y equals sine inverse x. Right, people? Y equals sine inverse x. Y equals sine inverse x. Right. Now, you know these people. You know, sine pi by 3, sine 60, no. Sine 60 is root 3 by 2. If you need to subject this left-hand side angle pi by 3, how to subject that, people? We take this sine to right-hand side and we write it sine inverse. Then pi by 3 angle in the left-hand side can be subjected right in this way. Sine inverse root 3 by 2. Sine angle equals a value. Then the angle subjected like this, sine inverse. People, then using this, how to convert this to this form? Bring this sine inverse to left hand side, this minus 1 will disappear. Then like that here, y equals sine inverse x. Bring this sine inverse to this side. Then we can write, people, y equals sine inverse x. Bring this sine inverse to this side. That minus sign will disappear. Then we get sine y equals x. People, sine y equals x, you can write as, people, x equals sine y. Then you can differentiate what, people? We can differentiate and find what? Dx upon dy, because the right hand side y, right hand side later only should come to left hand side denominator. Then we can find dx by dy. By finding dx by dy and convert that to dy by dx and take this answer dy by dx, I will give 2 minutes. Then here we can write, people, dx upon dy. What's that? Derivative of sine is cos. since here we have y cos y. Now we can write dy by dx is equal to 1 upon dx upon dy. Then dy by dx is equal to 1 upon dx upon dy is cos y. But you can write, people, cos squared y plus sin squared y equals 1. Right? Then we can substitute for sin squared y, because sin y is x, put that here x. Then we get cos squared y plus x squared equals 1. Subject this cos squared y, taking this x squared to right hand side, 1 minus x squared. People here, cos y we subject, put in the square root there, we have to put plus or minus. Right. Now we substitute that, but dx by dy, this cos y here. Right? Therefore, dy by dx we get as 1 upon, here, dy by dx is 1 upon cos y, people. 1 upon cos y, right? 1 upon cos y. This cos y is plus or minus square root 1 minus x squared. Here, people, out of this plus and minus, we select the plus sign. The reason we can explain, in the sin inverse x graph, we didn't draw the sin inverse x graph in the trigonometry. In the second part of trigonometry, we discussed that. When we draw the sin inverse x graph, in its principal part, its gradient is positive, therefore we select the positive sign. So then we'll write the reason here, selecting positive sign. The reason we will understand when we do that second part of the trigonometry, right? When we construct when we draw the graphs, right? So therefore, choosing, take plus sign, then we get d over dx, y is sin inverse x. Sin inverse x, this is equal to 1 upon square root of 1 minus x squared. This way. The root of sin inverse x is this, people, right? Right. You should remember this. You have memorized this, people, right? Okay. People, second one, take y equals cos inverse x. Take y equals cos inverse x. Right now, start. Take second one is y equals cos inverse x. Second inverse function. Right, this gives us, bring this cos inverse to this side, cos y is equal to x. That means x equals cos y. Then one derivative here we can find, people, dx upon dy. When we differentiate cos, what the answer we get? Minus sin, no? Then it is minus sin y. When we differentiate cos, we get minus sin. Minus sin, here y, no? Y. Then dy by dx is what, people? Dy by dx means 1 over dx upon dy. 1 upon, here we must write dx upon dy, but dx upon dy is minus sin y. Right. Okay. Now again you can write sin squared y plus cos squared y equals 1. But here cos y is x. Put that x here. X squared. We get this Take the right hand side and subject sine y. Sine squared y is 1 minus x squared. Then sine y is, people, the positive or negative square root of 1 minus x squared. Okay, sine y is this. Right now? Then I am going to substitute for this sine y, these two answers. This answer really, people. Huh? Therefore, dy by dx, we can write 1 upon minus this minus sine y. Sine y is this, plus or minus square root of 1 minus x squared. People, this minus and this plus, when you multiply, we get minus and plus make minus, minus minus plus, right? So then we get dy by dx is equal to 1 upon minus and plus make minus, minus and minus make plus, this way 1 minus x squared. Here, people, we select the minus sign. The reason is, in the cosinus x graph, when we draw, in its principal part, the gradient of the cosinus x graph is negative. That's the reason, right? Take minus sign. Then we get dy by dx is equal to minus 1 over square root of 1 minus x squared. So therefore, we get the result like this. Y is cosinus x. Then derivative of cosinus x with respect to x is minus 1 upon square root of 1 minus x squared. You see. Right? And people, take third one as y equals tan inverse x. Take third one as y equals tan inverse x. Take next one is y equals tan inverse x. Y equals tan inverse x. Right. Do this, people. Right. Take this answer. Y equals tan inverse x. Right. Y equals tan inverse x mean right. Bring this tan inverse to this side. Tan y equals 6. Tan y equals 6 mean, people, x equals tan y. Today we found the derivative of tan x. People, what is the derivative of tan x today we found? Derivative of tan x is sec squared x. Right now? Yeah. Then we can write what derivative we can find, people? Dx upon dy. The right hand side letter only, it should come to left hand side denominator. Dx upon dy is tan derivative is sec squared. Tan derivative is sec squared. Therefore, this is sec squared y. But we need, people, dy by dx. Dy by dx is 1 upon dx upon dy, no? Then substitute for this dx upon dy, this answer. Dy by dx is equal to 1 upon dx upon dy is this sec squared y. But you know, in trigonometry, we learned one formula like this. What? 1 plus tan square theta is equal to sec square theta. 1 plus tan square theta is equal to sec square theta. So therefore, this sec squared y I can write as 1 plus tan squared y. But tan y here x, put here x, then we get dy by dx is equal to 1 over 1 plus x squared. But y is here tan inverse x. Therefore, we get the final answer d upon dx tan inverse x is equal to 1 over 1 plus x squared. Right. This is the derivative of tan inverse x. All this result you have to remember, people. Right now, right. People, another two theories today I suppose to discuss. Then next day we can come to questions directly, right? Any question up to here? No questions. Right. Right, now we'll come to the next one, people. Try to next one. The derivative of y equals x to the power n. Y equals x to the power n. This n is a rational number. Where n is a rational number. Where n is a rational number. People, what is meant by a rational number? Rational number are those, people, now suppose we consider 10. This 10 we can write as a fraction like this, 10 by 1. 0.75. Right? We can write this 0.75 as 3 by 4. And people, take this 0.333 this way, recurrent decimal. We can write this as 1/3. So people, if any number which can be written as a fraction form like this, fractional form like that, that kind of number is called as, people, rational number. Any number which can be written as a fractional form like this, which can be written as a fractional form like this, is called as a rational number. Some people, numbers available, they cannot be written in this form as a fraction, especially when we consider root 2. The answer of this root 2, people, we can't write as a fraction. And when we write its decimal expansion up to 3 decimal places, 1.414 and so on, we get. When we very carefully analyze the decimal expression, people, in the decimal expression, you can't see any pattern. Those kind of, people, fractional decimal values are called as what? Yes, people, they are called as the, yes, people, what are the name for them? There are decimals, finite decimals, recurrent decimals, and infinite decimals. Finite decimal is, people, this kind of decimal is called as finite decimal. Recurrent decimal is this kind of decimal. The same digit or sets of digit repeating again and again. This one, people, when we notice by writing the next decimals, you can't see any what pattern of coming these decimal digits. Such are called as infinite decimals. Those infinite decimals are, people, the irrational numbers. The irrational numbers. Excluding the infinite decimals, the rest ones are called as the rational. So therefore, rational number always we can write as a fraction of the form p by q. This way we can write a rational number. So therefore, this n is not like this root 2, a number not like this root 2. Understood, right? Now, we can write the derivative of this. Now, you can assume this xn as your fx. Then we can apply directly what, people? The definition of the derivative. Write down. Apply the definition of the derivative. By the definition, dy by dx is equal to limit delta x going to 0. What is, people, first function? Fx plus delta x minus fx divided by delta x, no, this way. Fx plus delta x means on the right hand side every x we have replaced by x plus delta x. So and we get dy by dx limit delta x 0 here x we have replaced by x plus delta x, that to the power n minus the same fx x power n divided by delta x. Right, this way we can write. Now, this denominator, I can, people, rearrange like this. Here we have x plus delta x to power n minus x to power n. This delta x I write, people, like this: x plus delta x minus x. What do you say? X and this minus x will cancel off. No, only delta x here we have. Right. People, now see here this way. Here limit delta x going to 0. No, this expression only here I have to write. Now I take like this. People, what happened to this x plus delta x while delta x going to 0? Suppose here delta x limit going to 0. Delta x limit going to 0. When delta x limit going to 0 means this is 0, no? Then this x plus delta x to this sum, what happens? To this x plus delta x sum, what happens when this delta x going to 0? Then this x plus delta x will go to what? X, no? Can you understand? People, right? We have x plus delta x, the sum. This delta x part is going to 0. Then x plus this part will be going to x. Is it clear? So therefore, people, delta x, when delta x going to 0, it means this sum going to x. Conversely, people, when x plus delta x sum is going to x mean, it says delta x going to 0. You can very clearly understand it like this. Now, in the morning, people, you have 100 rupees and 50. Right. This 50 rupees, now you are spending for your expenses. Then what happens to this 50? Gradually, this is decreasing to what? 0. Then what is the amount of money gradually remain with you? Since this 50 going to 0, why? We are spending that, no? Then this 100 and that sum will going to what 100, no? Like that. X plus delta x we have, but this is going to 0. Then this sum will go to what? X. So therefore, people, x plus delta x going to x really means delta x going to 0. And delta x going to 0 really means x plus delta x going to x. So therefore, here people, I can write this one only I must write here. But we know as limit delta x going to 0, x plus delta x goes to x. Understand? So therefore, without writing this, the same thing I write in another way, limit x plus delta x going to x. Understand? And then I can write here limit x plus delta x goes to x like this. Understand? That way we can write. Now, can you remember, people, in limits we discussed one theory. What is that theory? Xn minus an divided by x minus a under the limit x going to a. Here, when we ignore these powers, what do you get? X minus a, that is here at the denominator. And under this limit, this one goes to a here. People, similar situation available here. When we ignore this power n and this n, what do you have? X plus delta x minus 6. That is at the denominator. And under this limit, this x plus delta x goes to a x here. Then this answer, people, we notice what is this answer? Na n minus 1. We proved that. N means this figure. A means this figure. N minus 1. Then what is the answer here? N a is x now. N x n minus 1. So therefore we get, therefore dy by dx we get as n x n minus 1. The reason is, we can write reason here as limit x going to a, xn minus a n divided by x minus a is equal to n a n minus 1. This one we proved. So therefore, we can write d upon dx xn is equal to n x n minus 1. We can write it like this, n x n minus 1. n x n minus 1. What is this result, people? For example, y equals x to the power 5. This n is 5. Then what is the derivative? Here, x to the power n, when we have n comes before x, subtract 1 from this n and write the power. I like that. What is dy by dx here? Dy by dx is equal to 5 comes before x, 5 minus 1. Then dy by dx is, people, 5x4. 5x4. So what is next? Next example, suppose y equals x to the power minus 3. Y equals x to the power minus 3. dy by dx. Take this minus 3 before. Minus 3 x minus 3 minus 1. Then dy by dx equals minus 3 x to the power minus 3 minus 1 is minus 4. Another one will take. Suppose, people, like this. Third example, y equals 1 upon x to the power 4. Here you can't write the derivative of this as dy by dx as, you can't write 1 upon applying that result here, you can't write it like this. This is completely wrong. What here you have to do first is, people, this x to the power 4 you have to bring to numerator as x to the power minus 4. Now only this is available in the form y equals x to the power n. People, in this case, the theory, when we prove the theory, this x to the power n should be at the numerator. Denominator should be 1. Here also, this has to be formed to that. Taking this numerator, keeping that x to the power something is at the numerator. Thereafter only that result we can apply here. In this case, x to the power n is denominator is 1, no, people. Then x to the power n should be at the numerator. Then this is the one. Now we have differentiate by applying that result. Then what is dy by dx? Bring this minus 4 before, x minus 4 minus 1. When we get dy by dx is equal to minus 4, x minus 4 minus 1 is minus 5. Right. We'll take another one, people. Y equals x. Y equals x. This we mostly use in calculations. Y equals x. Y equals x means what, people? The power of x is what? 1. Bring this 1 before. 1 times x. The new power is 1 minus 1. dy by dx. 1 times x. 1 minus 1 means 0. But x power 0 is, people, 1. Then we get 1 into 1. dy by dx is 1 now. Therefore, remember, this result is important. Very often we use this result when we work out questions. When you differentiate x, the derivative is 1. When you differentiate x, the derivative is 1. When you differentiate x, the derivative is 1. Right. Write down this results, people. Those results we take by using the result this. Right. Now, the one more we discuss, people, today before coming to the end of the lesson. Right. Okay. Right. Okay. Now people will come to the next heading like this, subheading like this. Derivative of a constant. Derivative of a constant. Derivative of a constant. Right? Yeah. Derivative of a constant. People, constant means a real number which doesn't change. For example, if I take y equals 5, 5 is a constant. In the OXY Cartesian coordinate plane, when we draw this y equals 5 graph, it is a straight line. It is a straight line. Cutting the y-axis at 5 and parallel to x-axis like this. This is the 5 point. You can see this line is parallel to x-axis. Here, people, when we consider any point on the line, its x coordinate is x, but always the y coordinate is this 5. This height is always the same 5, no? This is x now. Now, in this case, if we increase this x by a little value delta x, suppose this is delta x, the new x value is x plus delta x. subject to the new x value. What is new y value? New y value is as before the same 5, since the graph is parallel to x-axis. So therefore, though x increases by little value delta x, no change in y. Change in y usually we denote by delta y, no? Delta y becomes 0. Understand? So from there only we start the part now. Okay? Write down let y equals c, where c is a constant. Where c is a constant. Where c is a constant. Now people will draw a small diagram there. Y equals c, when c is a constant, it's a straight line. Parallel to x-axis, cutting the y-axis at 0, c. This height is c. These two are parallel. If I take any point here as p, xc, this is x. When you increase this by delta x, you can see still the y is the same, doesn't change. Okay, all right, draw that diagram. Draw that diagram. Right. Now you can write here, write down like this. Write down, let the increment in simple x, let the increment in simple x be delta x. Then the corresponding increment in simple y be 0. That is delta y equals 0. That is delta y equals 0. Now, people, you can write delta y 0. Divide both sides by delta x. Then delta y divided by delta x. 0 divided by delta x. You know, 0 divided by delta x means when the numerator is 0, the fraction is 0. 0. Then delta y by delta x equals 0. Now we take limit delta x 0 on both sides. Take limit delta x going 0 on both sides. People, here, what is the notation here we put? Delta y divided by delta x. The both numerator and denominator letter is delta. The denominator going to 0. Then this whole thing we write as a notation, change in this delta to d, dy by dx. Right. People, now on the right hand side, see here 0. 0 means a real number. It is a fixed value. Delta x going to 0. Delta x means increment of x. Though this x increase or decrease or whichever it is, the real number on the number line, this 0 cannot be changed because it's a fixed value. That is why it is known as a constant 0. 0 nobody can change. So therefore, though this delta x going to 0, 0 doesn't change. So therefore, the right hand side is 0 still. What is y? Y equals c. That says what, people? The derivative of a constant is 0. Therefore, derivative of a constant with respect to x is equal to 0. This is the result. Derivative of constant is 0. That means, examples when you consider y equals 2. 2 is a constant. dy by dx equals 0. Number 2, y equals 100. dy by dx is again 0. This is how people we apply this result. Write down the examples also. Write down the examples.